Hello everyone, welcome back. So last time we've talked about the chapter 1 of our text, and we've solved a couple exercise problems. So this was what we've done last time. First, we have distinguished the simple problem from the complex problem. And we have also learned about 9 different steps for problem-solving, decision-making processes. So first, today, we're going to solve several more problems from our text. And then we will talk about chapter 2, okay? Okay. So let's consider problem number 1-31. So apply the steps of the decision-making process to your situation as you decide what to do after graduation. Probably the most common large problem faced by undergraduate engineering students is where to look for a job and which job offer to accept or things like that, right? And last time we've learned there are 9 different steps for engineering decision making. And according to our text, one of the possible way of decision making would be like this. So, step number 1 is recognize problem. Right? So, you are going to graduate, and you need to decide what you are going to do. That is the recognizing the problem, right? So you're going to write down this way. I'm going to graduate. And I need to decide what I'm going to do, right? Could you zoom out a little bit so that student can see all the writing? Okay, and the next step, step number 2, define the goal or objective. So you do not want to move back and with your parents. And you would much rather be independent, probably, live on your own and do something that you really enjoy. So that is the probably goal. Sorry, is the goal or your own objective. So I would be independent. And I would really enjoy something. And then move on to step 3. You need to assemble relevant data. So, such as, how much money do I need to live? And where would be best for me to live so I can continue with my favorite activities and things like that, right? So, living cost, favorite activities, and in such case, if you want to continue your study in the graduate school, you might want to see if the teaching assistantship or research assistantships are available if you apply for graduate school. So, for example, graduate assistantship. And of course, some of you might consider it's very important how close your living place is, how close to your own family is, and any jobs available that allow you to do what you really enjoy, things like that. So you need to collect those informations. Okay. And step number 4 is identify feasible alternatives. So find a job near your hometown or at least in your home state. Might be your concern, and applying for graduate assistantships at several universities, things like that. So apply for graduate assistantship and find a job near your hometown, maybe. And then we're going to move into step number 5. Step number 5 is the selecting the criterion, right? So selecting the criteria to determine the best alternatives. Those criteria could be Does it provide you with enough money, or are you able to continue with your favorite activities, and whether you can enjoy what you will be doing or not, things like that. So will I enjoy what I will be doing? Whether you can enjoy maybe are you able to continue with you the favorite activities? And does it provide you with enough money? Things like that. These are just an example, right? You might have different answers, of course. And then we're going to move on to the next step, step number 6. We need to construct a model. So list possible job activities and study topics and assign each a number. For example, from 1 to 10, based on personal preferences, and list favorite activities and assign each a number between 1 to 3, depending upon how much you like to do it. So you might want to list possible job activities and study topics and assign each a number from 1 to 10, just for example, based on your preference. Okay. And then list favorite activities. And assign each a number between 1 and 3. Okay? So for example, assign the number 1 for below acceptable range, and 2 for within acceptable range, and 3 for above acceptable ranges. Okay? And then step number 7. Predict each alternative's outcomes. So for this scenario, there will be two steps here. First, use the model. And decision criteria. To decide to which job and graduate schools to apply. And then when you receive offers, use the model again. And then step number 8, choose the best alternatives. So what you need to do is choose the job or graduate school offer having the largest number. Okay? Choosing the job or graduate school offer having the largest number. Okay? And then the final step, step number 9, audit the result. So, for example, in 6 months, reflect on your decision. You're going to ask the following questions. Are you happy in, let's say, 6 months? Reflect on your decision. You're going to ask, are you happy? And what about the money? Have you earned enough money to live on? And probably you might also want to ask if you are doing, are you doing activities that you enjoy? Okay. So again, just tell you what I did for this question is one of the possible answers. So many of you might have different answers depending upon your own situation, right? Okay, now How about problem 1-40? So increasing population and congestion often are addressed through road improvement projects. This may pit the interest of homeowners and business owners in the project area against the interest of people traveling through the improvement projects. And what are some of the ethical issues that can arise in this case? So ethical issues that might arise includes the followings. The road improvement may be intended to benefit a new large business at the expense of existing small business who lose business during the construction and or who suffer parking loss after the construction. Okay? So the road improvement may be intended to benefit new large business at the expense of existing small business. Who lose business during the construction and or who suffer parking loss after the construction. Another ethical issues that might arise would be local business may lose business because commuters can travel through the area much faster. Okay. And also road improvement. Usually mean widening. So local residents local residences and businesses may lose. Property to the improvement. Okay. So of course, this is one of the possible answers. Okay. Okay, then let's consider problem 1-57. And actually, you will notice that some of these numbers are different from our textbook problem 1-57. That's why I mentioned here is the modification of problem 1-57. Okay. So Willie travels from city to city in the conduct of his business. Every other year, he buys a used car for about $12,000. And the dealer allows about $8,000 as a trade-in allowance, with the result that the salesman spends $4,000 every other year for a car. Willie keeps accurate records, which shows that all other expenses on his car amount to 22.3 cents per mile for each mile he drives. Willie's employer has two plans by which salesmen are reimbursed for their car expenses. So these are the two plans. The plan A is Willie will receive all his operating expenses, and in addition will receive $2,000 each year for the decline in value of the automobile. The plan B, Willie will receive 32 cents per mile, but no operating expenses and no depreciation allowance. Now, if Willie travels 18,000 miles per year, which method of computation gives him the larger reimbursement? At what annual mileage do the two methods give the same reimbursement? So there are two options available. So let's work on the plan A first. That is actually, I would say, itemized expenses, right? So for the 18,000 miles, he will receive how much? $0.223 per mile, right? Because 22.3 cents is $0.223. And plus, he will receive $2,000 each year. Therefore, it's going to be 0.223 times 18,000 miles plus $2,000. What is this amount? According to my previous calculation, it's going to be $6,014. What about plan B? Plan B is based on the standard mileage rate, right? So plan B based on standard mileage rate. So he will receive how much? $0.32 per mile. For 18,000 miles, right? According to the description. So the required calculation is 0.32 times 18,000 miles, which is $5,760. Okay? So if you compare these two plans, Plan A provides $6,000 and Plan B is $5,760, which means this Plan A, itemized expenses, produces a larger reimbursement. And we also need to answer for the second question. At what annual mileage do the two methods give the same reimbursement? So how do you answer this question? For answering this second question, we need to calculate the break-even point, okay? So if we let X is the mileage at which both methods yield the same amount, then from the itemized expenses, we're going to use this formula. Okay? So basically, we're going to use 0.223 times X instead of 18,000 miles plus $2,000. And from Plan B, we're going to use this formula as well. Is equal to 0.32 times X. Again, instead of 18,000, we're going to use X. So here, 2,000 equals 0.32 minus 0.223 times X, right? And so X would be 2,000 divided by 0.32 minus 0.223. This is 20,619 miners. Okay? So, in these miners, the both method provides the same reimbursement. Okay? Okay. Then next, let's consider $66. And we're going to see that those numbers are slightly different from the original problem, 1.66. Okay? So a manufacturing firm has received a contract to assemble 1,000 units of test equipment in the next year. The firm must decide how to organize its assembly operation. Skilled workers at $22 per hour each could be assigned to individually assemble the test equipment. Each worker would do all the assembly steps, and it would take 2.6 hours to complete one unit. And an alternative approach would be to set up teams of 4 less skilled workers at $13 per hour each and organize the assembly tasks so that each worker does part of the assembly. The foreman team would be able to assemble a unit in 1 hour, which approach would result in more economical assembly. So there are two different approaches, right? So I'd say the first methodology is individual assembly. We need to pay $22 per hour for a skilled worker, and it would take for him 2.6 hours, right? To complete one unit. And the firm has a contract to assemble 1,000 units. So you need to multiply these three numbers, right? Which will give you $57,200. So this tells you $57.20 per unit. Is that right? For the second method, the team assembly plan, we need to pay $13 per hour for each 4 less skilled workers. So you need to multiply by 4 because there are 4 workers in this team. And the foreman team spent 1 hour. So you need to multiply by 1 hour to assemble 1 unit. And the firm, again, has the contract to assemble 1,000 units. So you need to multiply all these 4 numbers, which will give you $52,000, which means that $52 per unit. Okay? So how do you answer this question? The team assembly is less expensive, right? Just comparing these two numbers, team assembly provides smaller number. So we recommend this method for team assembly. Okay? Okay, so now let's move on to chapter 2. So in this chapter, we will learn about various cost concepts and cash flow diagrams. Okay? So the understanding the engineering cost is fundamental to the engineering economic analysis process. And these are the fundamental cost concepts provided in our text. I will just briefly talk about each of these costs, which means that I'm not going to go through all the details of these cost concepts during the lecture. So please read the corresponding content of the text. Okay? Okay, so the fixed costs are the constant regardless of output or activity. And variable costs are changing, and they depend upon the output or activity level. And many universities charge full-time students a fixed cost for 12 or more hours each semester, and a variable cost per credit hour for each credit hour over maybe 15 or 18. So for the full-time students who are taking more than 15 or 18 hours, they will be charged both fixed and variable cost. Is that right? And both fixed and variable costs are used to find a break-even point between costs and revenues, as well as the net profit reason and loss reason. So like it says here, break-even point is the level of activity at which total cost for the product, good, and service are equal to the revenue generated. And this is the level at which one just breaks even. Profit reason is the values of the variable x greater than the break-even point, where total revenue is greater than total cost. And loss reason is the values of the variable x less than the break-even point, where total revenue is less than the total cost. So basically, if I draw the line, so the horizontal line, horizontal axis represents the production quantity, let's say, production quantity. And the vertical axis represents the dollar amount, okay? And this is about the break-even analysis. Okay? Now let's say there is a fixed cost. And there is a variable cost, something like this. And what would be the total cost? Total cost would be something like this. that has the same slope as the variable cost, right? So the total cost. What about the total revenue then? Starting from 0, total revenue would be something like this, let's say. Okay? So we have total revenue. Then of course, this area represents the loss region. And this area is the profit region. Okay? Then where do we have a break-even point? Right here. So we have right here break-even point. Okay? So just as an example, this is very similar graph that I drew just ago, right? So this figure illustrates the break-even analysis for our text example 2-1. So in this case, the total number of students at which the total cost equal to the total revenue is right here, which is 15 students. Okay? And just to let you know that this break-even analysis can be used for determining minimum production quantity and forecast production profit and loss in reality. Okay? Okay, now let's take an example for the break-even analysis. This is the modification of the problem, end of chapter problem 2-7. Okay, so a privately owned summer camp for youngsters has the following data for a 12-week session. So charges per camper would be $120 per week, fixed cost the $48,000 per session, and variable cost per camper is $80 per week, and capacity is 200 campers. And the question A is develop the mathematical relationships for total cost and total revenue. So, first of all, if I define X is the number of campers, okay? Number of campers, then the total cost would be fixed cost plus variable cost, right? So fixed cost is how much? Here, 48,000. What about the variable cost? Variable cost is $80 per week. And how many weeks do we need to consider? There are 12-week sessions, right? So what you need is $80 per week times 12 weeks, right? Times number of campers. Is that correct? So what you have is 48,000 plus 960x. Okay? That is your total cost. Then what about the total revenue? That's going to be $120 per week. So $120 per week. Again, we are considering 12-week sessions. So you need to multiply by 12 weeks times the total number of campers, right? So this is going to be 1,440x. Okay? And what about question B? What is the total number of campers that will allow the camp to just break even? So we know that break even occurs when the total cost equals the total revenue, right? So, like I said, break even occurs when total cost equals total revenue. Which means our total cost was this, right? So 48,000 plus 960x, and total revenue is 1,440 times x, right? So we're going to set equal to 1,440 times x and solve this equation. So 48,000 equals 1,440 minus 960 times x. This is 480 times x. So what is the value of x? X is 100, right? So 100 campers to break even, okay? Okay, then what about question C? How to answer question C? What is the profit or loss for the 12-week session if the camp operates at 80% capacity? What is the capacity of the camp? 200 campers, right? So capacity is 200 campers. So 80% of campers, 80% of capacity is 160, right? 160 campers. So at 160 campers, the value of x becomes 160. The value of X equals 160. Okay? So now the total cost is 48,000 plus 80 times 12 times X. X is 160, right? So total cost would be $201,600. Likewise, with X equals 160, total revenue would be 120 times 12 times 160, which is 230,400. Okay? So how did you get the profit? Earlier today, I mentioned profit is revenue minus cost, right? Revenue is this, 230,400, and cost is 201,600. So the profit would be 28,800. Okay? So this is the answer for question C. Okay, so next is about the marginal cost and average cost. So the marginal cost is the variable cost for one more unit of output, which means it is used to decide whether an additional unit should be made, purchased, or things like that. And the average cost is the total cost divided by the total number of units produced. Okay? Next is about the sunk cost and opportunity cost. The first, the sunk cost is the cost that has occurred in the past and has no relevance to estimates of future cost and revenues related to an alternative. Okay? So these are the monies already spent as a result of a past decision, which means sunk cost must be ignored in the engineering economic analysis because current decision cannot change the past. Okay? What about opportunity cost? Opportunity cost may be considered a cost of the foregone opportunity. That is, this cost involves the benefit that is foregone when you choose to use a resource in one activity instead of another. Recurring costs are the cost that occurs at regular intervals. So the recurring cost can be explained and anticipated expense. Whereas the non-recurring costs occur at irregular intervals. Incremental costs are the difference in cost between two alternatives. And we will use this cost concept in the incremental analysis later in this semester. Okay? And cash costs are the cost that involves money and cash transactions. And these costs are the basis for engineering economic analysis. The book costs, the costs that do not involve money cash transactions. And usually the book costs listed in the firm's accounting books. And usually these costs are not included in the engineering economic analysis. Okay? And like it says, life cycle costs are the summation of all costs related to a product, system, or service during its lifespan. Of course, we must consider life cycle costs when we choose a product, system, and services. Okay? Okay, the CFD, the cash flow diagrams, is a picture of how much money is spent or received over time. So it summarizes an engineering project's economic aspects. And it is used to model the positive and negative cash flow of potential investment opportunities. And the cash flow diagram's horizontal axis represents time. And the time units on the cash flow diagram can be years, months, quarters, semesters, and weeks or day, or any other consistent time unit. And the vertical axis represents dollar amount, and arrows show the timing and amount of revenues. Those are the receipts or benefits, and costs. Those are the expenses. Okay? And the receipts or benefits are drawn as positive arrows. That is, arrows pointing up. And cost and expenses are drawn as negative arrows. That is, arrows pointing down. Okay? So, keep in mind this, let's consider a textbook example like this. We are given a specific investment plan in this screen. So we'd like to draw a cash flow diagram based on this table of cash flows. So the horizontal axis represents time. Okay? And the vertical axis represents dollars. And the arrows shows the timing and the amount of revenues and cost. Right? And the arrows pointing up represents the positive cash flow. And because here at time 0, which is right now, the positive $100. So we're going to have positive cash flow like this, and then put the number 100. And then we mark the time 0 here. And one time period from today, we have negative of 100. So we have like this, negative 100. You remember the arrows pointing down represents the negative cash flow, which means you don't need to put negative sign here. Okay? And what about 2 time periods from today? 2 time period, we have positive 100. So we were going to draw like this. And 3 time periods from now, negative 150. So we will have this 150. Okay, and 2, 3, let's say 4. We have again negative 150. So we have 150. Let's put negative 4 down here. And then 5. This is the last one, right? 5 time period from today, we have positive 50. So we have 50 like this. So this is the complete cash flow diagram based on this cash flow table. Okay? Okay, so the expenses and receipts due to engineering projects usually fall into one of these categories. So the first cost, expenses to build or to buy and install, and operations and maintenance cost, O&M, is the annual expense, such as electricity, labor, and minor repairs. The service values are the receipt at project termination for sale or transfer of the equipment. And revenues are the annual receipt due to sale of products or services. And the overhaul is the major capital expenditure that occurs during the asset's life. Okay? And when you draw a cash flow diagram, you need to keep in mind that rent, lease, and insurance payments are usually treated as beginning of period cash flow, whereas operations and maintenance expenses and service values, revenues, and overhauls are assumed to be end of period cash flows. Okay? Okay, then let me stop here for today. So next time, we are going to solve a couple end of chapter problems from chapter 2, and then we will going to move on to the chapter 3. So please read the chapter 3 before you watch the next recorded lectures. Okay? Thank you very much. See you next time. Bye.